Restoring vision and stopping blindness are not the same thing. That single idea causes more confusion and more heartbreak than almost any headline about stem cells and vision. When people hear stem cell therapy, it's natural to imagine eyesight coming back the way it once was. Reading signs again. Recognizing faces. Seeing fine detail. But science is telling a more careful story. Most of us assume vision loss works like a broken part, replace the damaged cells, and vision returns. In retinitis pigmentosa, it's not that simple. RP doesn't just affect one type of cell, it slowly disrupts an entire visual system, including how the eye and brain communicate. Here's the key distinction. Cell replacement is not the same as functional vision. Some stem cell approaches aim to replace lost photoreceptors, the cells that sense light. Others aim to support surviving cells so they last longer. But even if new cells survive, they still have to connect correctly, send signals, and be interpreted by the brain. That's an extraordinarily complex process. This is why many current trials focus on light perception rather than detailed vision. Being able to sense light, shadows, or movement may not sound dramatic, but for someone with RP, it can mean safer movement, better orientation, and greater independence. It's the difference between complete darkness and having reference points in the world. And that matters deeply. Research isn't just about reading eye charts. It's about quality of life, navigating a room, finding a doorway, sensing where people are. These are meaningful gains, even if they aren't cures. At the same time, it's important to be honest. Stem cell treatments today face real limitations. Long-term safety, durability of the cells, and consistent functional improvement are still being studied. Progress is measured in careful steps, not sudden breakthroughs. But here's the hopeful part: every trial, successful or not, teaches researchers how vision works, and how it might be rebuilt one layer at a time. The goal isn't false hope. It's informed hope. In future research, the question isn't just can we restore vision? It's how much function can we preserve, support, and eventually rebuild? And that question is moving science forward, carefully, responsibly, and with patience at the center.